Hi everyone and welcome back to PrepFusion. So today we'll start a new topic of calculus chapter, that is indefinite integration. So up until now we have been studying about derivatives, differentiation and partial derivatives. We learned about maximum minima, application of derivatives and like mean value theorems, all those things. So in this lecture we will study indefinite integration, and in the next lecture I will do questions on indefinite integration. Now remember that this chapter in terms of weightage is not that important, okay, but if you don't understand this like indefinite integration, then you will not be able to solve the multiple integration. So it's very important to understand indefinite integration, but it's okay to not practice so many questions, because you don't have to invest too much time in this, because other chapters are more important than this. So just quickly scroll through this. I know, yeah, you have studied already this in class 11th or 12, so just go quickly through this so that you can cover other topics, okay, which are related to this. So first of all, let us understand for the people who don't know that, like, integration, right? Like, what does integration mean and how many types of integration are there? So mainly, like, integration is the reverse process of differentiation, and integration are of two types, okay. One is indefinite and definite integration. So indefinite means the limits, I don't have any limits, no limits, okay, no limits. Okay, and like definite means I am integrating with respect to limits, and this is also known as area under the curve. We will understand this slowly when we will go along, okay, where a and b are called limits of integration. This will study after finishing the indefinite integration, okay, that this will be our next topic. So like here I have like written the definition of integration. Integration is the reverse process of differentiation, okay. So like this integration is also known as primitive or antiderivative. So I can name this integration as primitive, like indefinite integration, primitive or antiderivative. Okay, primitive antiderivative. So what can I say over here? That the differentiation of a function g of x is equal to f of x, that we know, that we have been doing, right? Differentiation of x square is 2x. Now if we do the opposite, the integration of 2x should give me x square, right? X square, which is known as integration, okay, as it is a opposite process. But I am also getting this extra term c over here. Why is this the case? So basically what I can say is that as I am differentiating this dg of x, okay, with d of x, so generally what we do, this is not like conventional, this is not written in book, but you can write it like this: d of g of x equals to f of x into dx. Dx is a small, very small number. Now if we take the integration on both sides, what will happen? Integration of d of g of x equals to integration of f of x d of x. Now we took the integration of both sides, and we know integration is the opposite of differentiation, so obviously this d will get cancelled. So I can write g of x will be equals to f of x plus c. Now why will this c come? This c will come because now if we differentiate this whole equation, what will happen? This will be ddx of gx into ddx of f of x. Now ddx of f of x this will be ddx of g of x, which is f of x itself. Okay, sorry, this is still in integration stage, right? Okay, my bad. Okay, I can't write this, sorry, my bad. So like that was different, I was explaining something different. So here what will happen is that integration and this d will get cancelled, and I will be left with this only. So this will be equals to g of x will be equals to integration of f of x d of x, okay. So basically the opposite process. So if I differentiate g of x, I am getting f of x. Now if I integrate f of x, I will get g of x. just the reverse process. Okay, so and this, right, this f of s is known as the integrand. Just basic terminologies, not that important. Okay, so this is known as the integrand. So now where does this c come from? That is very important, right? Where does this c come from? Because like here I have written this g of x equals to integration of f of x dx. Now here I have a c extra. Why is this the case? So this is the case because if you differentiate this, right, if you differentiate this equation, if I do ddx of integration of f of x, what will happen? Ddx and integration will get cancelled. So I will be left with f of x equals to this ddx of g of x and what is the differentiation of a constant? It is 0 only. It is 0 only. So that's why it doesn't matter. It doesn't matter, right, whether I have a constant or not. Okay, but why is this constant coming? This constant is coming because when I differentiate, right, if I differentiate g of x, I will get f of x. If I differentiate g of x plus 1, still I will get f of x. So that's why, as it is a reverse process, I don't know for sure what exactly is my function that I differentiated. Okay, it may be a family of curve. Okay, so let's take one example. Okay, let's take this. Okay, if my integrand is single one, okay, only one. Okay, if my integrand is 1, what will my y be equals to? Y will be equals to x plus c. Why c? Because now if I differentiate this, I will get a curve which has a slope of 1. Okay, but it also has a constant because this will go to 0 if I differentiate it, right? So one thing is for sure, if I differentiate this, my value will be 1. Okay, dy dx equals to 1. But if I integrate that, what I will get? If I integrate that, I will get x plus c. Okay, because I don't know from where it came from. So what do we mean? All of these curves, right? All of these curves have slope of 1. Like let me name this thing. So this is, let's say, x plus 1. This is x minus 1. Okay, then x minus 2. So the differentiation of all of this is equals to 1. Okay, so the integration of x can be integration of 1 can be any of these curves, right? Any of these curves. I don't know because if I integrate 1, all of these are possibilities because integration is reverse of differentiation. So I differentiate x plus 1, I will get 1. Differentiation of x, 1. Differentiation of x minus 1, 1. So all of them are giving the same thing. Okay, 1. So that is a problem with integration. So I have to add in a constant because this is the complete answer. Complete and correct answer. Okay, never forget the complete answer. Never forget the constant of integration in indefinite integration. In definite integration, the constant will get cancelled. Why and how? There I will explain. Okay, so this is the complete answer. Even if the x is correct answer, okay, if my c is 0, x will be correct answer, but this is not the complete answer. Only y equals to x plus c will be my complete answer. Okay, so now like these are few formulas, you have to remember all this. Like this is just a reverse process. It is fairly easier for you to remember. Just one thing to notice here is that integration of 1 over x is log of mod x plus c. Just don't forget the c also. Log of mod x plus c. Why mod? Because I know differentiation of log of x is 1 by x, but integration of dx over x is log of mod x plus c. Why is this the case? Because what will happen? Let's do this, right? Okay, y log of mod x, because what do? You differentiate with respect to what? Dx of log of mod x. Now I hope you know by now what is the differentiation of mod x. Differentiation of mod x is this will be 1 by mod x into differentiation of mod x, which will be mod x upon x. Okay, so where obviously my x cannot be equals to 0. This is the case. So what will happen? This mod x and mod x will get cancelled. I will be left with 1 by x. So I'm getting the same answer only. Getting the same answer. But what is the difference? The difference is this time, right, my x can be any value. X can be both positive and negative. X can be both positive and negative, right? So yeah, this is the case. That's why I take this. Else, if I would have only taken ln x like greater than 0, then what would have happened? I can only put positive values of x. I can only put positive values of x, but this time I can put any value of x, right? So that is the reason we use mod of x, okay, to use or like to use the whole range, because inside log function I cannot give negative numbers, right? So like there are a few more formulas like this, okay, the integration of tan x. So how you solve this? So I will just give you a hint, and then I will write the solution after the class is finished, because these things you have to do by yourself so that you can develop your intuition and conceptual knowledge, and this you have solved in class 10 also, or 11th 12 also, okay? So I won't waste much time in this. I will just give you a hint. What you do, you write tan x as sin x by cos x dx. Now what you do, you assume t as cos x, okay, and then you do the substitution, dt equals to minus of sin x dx, okay, simple substitution, and then you can integrate, okay. I won't explain further over here. Just hold on a second, let me check if everything is recording or not. Yeah, this is recording, fine, okay. Next, integration of cot x is minus log of cos x plus c, or you can say log of sec x plus c. Same method you use, which I used earlier in the previous question. Integration of cos of x equals to log of cos of x minus cot x. How do you use this? So what you can do, you can like either cross verify this, like it is 1 by sin x minus cos x by sin x, 1 minus cos x by sin x. Then you assume that sin x like 1 minus cos x by sin x. Then you can break this down into half angle formula, or yeah, or like cos 2x equals to sin square x, cos square x minus sin square x, that you can break down to, okay. From there you can solve further, okay. So yeah, this is how you can solve this. Then sec x integration will be sec x plus tan x log of tan pi by 4 plus x. Now this, right, you can always observe that with cot x there will be some negative sign involved, okay, when there is cosec x, okay. What are the most trigonometric like terms that we use? Sine we use, cos we use, sec we use, and tan. So cosec and cot are generally pushed off, right? You guys go, you guys have fun, but mainly we talk about those things, okay. So that's why cot has some negative, so that's why cot x has some negative. Anyways, whenever cosec x comes, it has some negative. When sec will come, it has some positive. That's how you remember sec x plus tan x. This is cosec x minus cot x, okay. So yeah, this is how you do this. So I won't like I will write the proofs, okay, how it came, but not in front of you. You try to do it by yourself so that you can remember like exactly how it came. So basically you can use the following formulas. Like you can either break down sin x into like here, if you have sin x, right, you can break down sin x equals to yeah, 2 sin x by 2 cos x by 2, okay. You can break down your sin x like this, and you can break down, like you can use this formula, cos square x equals to cos x equals to cos square x minus sin square x, okay. You can use these two formula, you can derive for yourself. Let's go to the next set of formulas. So here, if this is dx by 1 minus under root x square, this will be sin inverse of x. Now this, it will be minus cos inverse of x. Again, why is it so? Because I know that my sin inverse of x equals to pi by 2. Sin inverse of x plus cos inverse of x equals to pi by 2. Then yeah, and like sec inverse of x plus cos inverse of x will be again pi by 2. That's why they are negative of each other, right? They are negative of each other. So this is integration of, yeah, this integration I can write as sine inverse of x or minus cos inverse of x, because I can just replace sine inverse of x with pi by 2 minus cos inverse of x, and pi by 2 can be added with this constant. Okay, that is the reason. And here also my okay. So like there are a few theorems of integration that you already know, like it follows homogeneity, it follows superposition. So basically integration is a linear operator in linear process, like whatever differentiation was, it's the same only. So obviously it follows homogeneity, superposition, so like it is a linear process, right? Linear process. Okay, and now like this is what, like if I have a constant inside the integration that I can take outside, and if I have a constant and I have an integration like this f of lambda, okay, what I can do, I can bring this lambda outside, right? Okay, this is not lambda, actually this will be x. So I can simply bring the constant outside, right? Simply do that. Okay, as this is a constant, so I can simply bring it outside, and yeah, I can simply differentiate. Nothing much new to this. So like I will say a few basic examples. So let's do few basic examples. So if we have here 10 e raised to power x dx, 10 e raised to power x dx, this will be 10 e raised to power x plus c. Okay, because constant can come outside, right? So what is happening, I should write this like one more step. I directly written it, I didn't even use the property. So here it will be 10 integration of e raised to power x dx, and then obviously I can write it like this. Okay, and like let's take, this was the homogeneity, let's take superposition, e raised to power x plus 2 raised to power x dx. So this will be e raised to power, like I am individually integrating these things. Okay, I can do that, plus integration of 2 raised to power x dx. So this will be e raised to power x plus 2 raised to power x divided by log e of 2. Okay, or you can write ln of 2. And obviously don't forget your constant of integration. Don't forget your constant of integration, right? So yeah, this was the like examples. Now here I have few questions. So what I want you to do is try. So first this one I will solve, others you try to solve. Like there will be some trick involved. Whenever it is a question of indefinite integration, there will be some trick involved. Okay, so like adding one, subtracting one, like that's the thing. Okay, so yeah, let's start with the first question. You have to evaluate this, right? So how do you evaluate? So this, right, what I'm observing, this is a 4 which is 2 square, this is 9 which is 3 square, and this right here 2 times 3 multiplication. So this is like a plus b whole square formula. It is coming like in the bottom, this is like 2 times 5 raised to power whole x, this is 3 times 5 raised to power whole x. Again I'm getting 2 and 3, right? So obviously I have to use that. So integration of 2x whole square plus 3x whole square plus 2x into 3x. Okay, basically it was 6 raised to power whole 6 raised to power x. Now I can write this as 2 times 3, and then I can further break it down, and this is basically 5 raised to power x I can take in common, and this will be 2 raised to power x plus 3 raised to power x dx. And now what I can write it like this, that it is 2 raised to power x plus 3. So it will be 2 raised to power x plus 3 raised to power x whole square. Two raised to power x plus 3 raised to power x. So I'll be left with, okay, I have to do the integration also, don't forget. 2 raised to power x plus 3 raised to power x divided by 5 raised to power x dx. Now what I can do, I can again use the superposition. Okay, so this will be 2 by 5 raised to power x plus 3 by 5 raised to power x dx. Okay, so obviously this is the same formula, right? So this is 0.4 and this is 0.6. So this is 0.4 raised to power x divided by ln of 0.4 and plus 0.6 raised to power x ln of 0.6. Okay, ln of 0.6, right? So yeah, this is how you solve this question. This is the answer, plus c also, don't forget plus c. Okay, this is the answer to this question. So you try to solve the second and third one. Okay, there will be some minute trick involved. Now this, right, this how you can solve. So you can see some cos x sin x of same power are there, so you can write sin x cos x and convert it into that formula. So yeah, all those things you can do, right? So I am again telling you, these two identities are the most important one, that is like 2 sin x, like sin 2x equals to 2 sin x cos x, and cos 2x equals to cos square x minus sin square x. Okay, you use these two identities and you will be able to find your answer. In the next lecture I will solve all this. Okay, so now let's start with methods of integration. So what are my different methods of integration? So like you have already learned this, I think, substitution, then by parts, then partial fraction. So partial fraction is just simple mathematical manipulation, and this substitution is just like what he did in the starting, right? Here I did something. Which one? Where did it go? Why did I did the substitution? That is weird. I just did it right here. I substituted t equals to cos x, right? I created another variable and I substituted a is equals to cos x, and then I changed the variable. Like I haven't changed it, I have given you a hint. Okay, that is how you solve using substitution. I solve one question and from there we'll understand this better. Next is by parts. By parts is almost similar to chain rule, but it is much difficult because with integration, right, everything becomes difficult, and partial fractions. So we'll slowly solve these questions. Okay, now like what do you mean by integration? By substitution. So I have a integration g of f of x, like a composite function, and I have f dash of x. So what I can, f dash of x, what I can do, let f of x equals to t, then dt will be f dash of x dx. So dt about dx I'm doing, dt will be f dash of x dx. So what I can replace this f dash of x dx, I can replace with simple dt, and this will become g of t. Okay, g of t. So it will be much simpler for me to integrate that. When we will do examples from there we will understand. Let's just take this example, right? Here I have f dash of ax plus b. So what I can do, I can name this ax plus b as a constant. So ax plus b is equal to t. Now what I can do, dt equals to a, right, dx. Okay, because b is a constant, it will be 0. So now what I can do, basically this will be, if I integrate, what will this function become? This will become f dash of t dt into a also. Okay, like dx will be equals to dt upon a equals to dx. So I will divide by a. So like what will be the integration? 1 by a is constant, so 1 by a will come outside. And what is the integration of f dash of t? It is simply f of t. It is simply f of t. Okay, plus c also is there, plus c also is there. And what is t? What is t? T is ax plus b. Like I am integrating with respect to dt, don't forget. So that's why this became simply f of t. What is t? T is ax plus b plus c. Okay, x plus b plus c. So this is how you solve, like basic only, right? So like let's take an example. When will this be useful? So if I take an example, like let's say I have to find integration of x square. What will be this? This will be x cube by 3 plus c. Now I want you to find integration of x 2x plus 6 whole cube dx. Okay, oh yeah, you can do whole cube, whole square. Okay, I'll do whole square, same. I'll keep the theme same, dx. Now this is a bit tedious, okay, but with substitution I can directly write this. What will this? So this will be simply equals to, this will come in the bottom because I am substituting. Basically what you can write, I am substituting 2x plus 3 equals to t. So if I am substituting this, then what will happen? My dt will be equals to 2 dx, and my dx will be equals to dt by 2. Now what will happen? I can simply replace my dx with this. This will be t square dt divided by 2 equals to, this will be t cube divided by 3, and 3 times 2 is 6 plus c. Okay, so t cube is 2x plus 3 whole cube divided by 6 plus c. Okay, 2x plus 3 whole cube plus divided by 6 plus c. So this will be my answer. So like you could have directly would have gone to this step if you know like this 2 will come in the bottom, and due to this 2 another 3 will come in the bottom, 6, and simply this power will be raised to 3 and plus c. Okay, you could have directly done it. So that is how you solve using substitution. So here I have given you a question. These are homeworks. So you try to solve this. Just try to look carefully what function can you use to substitute. Basically you have to focus that whatever is multiplied with dx, okay, that will be my derivative. So the integration should be present somewhere, or you create that integration to simply use that as a function. Okay, then you can simply find this in the multiplication format. Okay, then you can solve. So just be careful in this function what you can substitute to get your answer. This also you have to be careful and choosy that what you can use to substitute to get to your answer. So this is multiplied with this dx. Okay, so yeah, this is how, like, these are the questions that you should solve. I will solve this in the next question. So another, right, like integration of a square minus x square, or x square plus a square, or a square minus a square, what will be the answer? So in general cases, these are few formula lists that what you have to do is that whenever this format is present, okay, this format is present, so I will write standard substitution. What is my standard substitution? So these are few standard substitution, right? So here a square minus x square is given. That means you have to replace a x with a sin theta or cos theta. Why is this the case? Because this will give you what? A square minus a square sin square theta, which is a square cos square theta. If I take a square common, or a square minus a square cos square theta, which will be a square sin square theta. Okay, so like something is coming differentiation of sin is cos, differentiation of cos is minus sin. Okay, that's why. Then x square plus a square, then you'll give a tan theta or a, okay, this will not be a, yeah, sorry for the interruption, my iPad just got crashed. So I will just write down the formulas. I was explaining the same thing only, that why do we replace, right, standard substitutions? Why do we have standard substitutions? So here what we do, basically I know the formula that I have sine square theta plus cos square theta equals to 1. Then this, if you remember this, that you have 1 plus tan square theta equals to sec square theta, or what you can write, 1 plus cot square theta equals to cosec square theta. And this, what we can write, this we can write as basically like the form. What is the formula is same only, this only, but I will write in terms of sec theta now. So this I can write sec square theta minus 1 equals to tan square theta. So this is what will be substituted. Basically here what I will do, I will replace this with a sec theta, then this a square I will take common, 1 sec square theta minus 1, and this will be replaced with tan square theta. Okay, so yeah, that is how you do. Next, or you can write like cosec cos square theta minus 1 equals to cot square theta. Okay, so yeah, this is how what you do. So here what will you use as your substitution? Basically you will use x equals to a sine theta, okay, or a cos theta, whichever is suitable to you. Okay, and you will get your answer. So like I will do all this in the after this lecture is over. I want you to try by yourself. Here I haven't given x square minus a square. So what will you use? You will use the last one, right? You will use the last one, a sec theta or a cosec theta. Okay, so these are the few formulas. You can try to remember all this. Okay, you can try to remember all this. You have to remember, just keep this in short notes. So that is my recommendation. Keep all of this in short notes. Okay, that is what I used to do also. This in short notes, and whatever previous formulas I have given you, you have to revise this daily revision. Okay, daily revision. So like these are the few formulas. Now what you can do, you can solve these questions again. Like this is another formula, so you have to put this in short notes. Okay, like everything is not important, but still if you remember this, well and good. If you don't, then it's becomes sad. So here I have a question. Okay, now what will you use here? So what I can see, can you see any substitution here over here? So like you might say, sir, I can use e raised to power 2x as my substitution, but the differentiation of e raised to power 2x won't be e raised to power x, okay, dx. It will be e raised to power 2x, 2 times e raised to power 2x dx. So not that helpful. So what I can do, I can, like I'm solving this question, I can assume that e raised to power x is my like what I am choosing as my variable, right? What I am choosing as my substitution variable. So here what I can write, that differentiation, like dt will be equals to e raised to power x dx, and e raised to power 2x, what will be e raised to power 2x? It will be simply t square. If I square this, it will be t square. So here this will be simply dt by t square plus 1. Okay, so this is how like all these formulas will get used. And generally in indefinite integration, what will happen is that a bigger problem, okay, you need to solve, and this will be the smaller problem. You have to solve this integration, then you will be able to get to your answer. Okay, there will be a bigger problem. Okay, so dt by t square plus 1 will be equals to, simply, if we remember the formula, 1 upon a tan inverse x upon a is 1 in this case, so it will be tan inverse of t plus c. And what is t? T is e raised to power x, so this will be tan inverse of e raised to power x. Okay, sorry, this isn't 1, this is actually 3 square. This is 9, right? 3 square. So this will be simply, okay, 1 upon a into x upon a, so it will be t by c. Oh, t is what? T is e raised to power x plus c. Okay, so this is how you solve. Like this formula is also, you use tan inverse formula, and also you will use the substitution. So you have to use both of these, so you have to be careful. So like next method of solving is integration by parts. So this is very important, you have to listen to me carefully. So chain rule was pretty easy, and here if I have multiplication of two functions which are obviously function of x, and I have to integrate with respect to dx, how will I solve? So first you will keep one outside, then you will integrate the other, then things will change. Here this is negative integration of du upon dx times, like whatever you kept outside, sorry, not integration, whatever you kept outside you will differentiate that, and whatever you kept inside again you will integrate, and you will multiply these two things, again you will integrate with respect to dx and subtract that, and that will be your final answer. Okay, so like is this really true? Okay, do we really get this? So what you can do, you can cross verify, okay, with differentiating, right? You can cross verify with differentiating whether you're getting the right answer or not. So let's check one thing, that if I differentiate both sides with respect to x, what will happen? If I differentiate both sides with respect to x, okay, so like what you do, you will just du upon dx integration uv dx equals to ddx u dot v dx. So differentiation of this minus in like differentiation ddx of this thing, right? So this is very big. This is for just your just for your peace of mind, that yeah, I'm getting the result. Okay, whatever written over garbage, whatever written is over here, this is true. Okay, so that's why. So differentiation of this thing, integration of du upon dx into integration of v dx. Okay, so this will be simply like differentiation of this will be simply u times v, right? So this will be u times v, and this here, right? I can apply chain rule. First I will differentiate with respect to this, then I will differentiate with respect to this. So if I differentiate with respect to that, this will be du upon dx, and obviously I will have a v dx at the outside. Now if I differentiate with respect to this will be outside, so this will be u times v simply. and I have a negative sign over here, and if I differentiate this, this will be remained with du upon dx into integration of v, du upon dx into integration of v. So what I can observe is this and this will get cancelled, and uv will be equals to uv. Okay, so like, yeah, true, LHS is equals to RHS, hence true. We are not proving anything, so we won't prove, hence true. Okay, so just for your peace of mind I solved this. So I hope you got the point that yes, this is true. So like, what you do in this chain rule, in this integration by parts, is that we have a islet rule, right? Because I have two functions u and b, like question may arise that which function I should integrate and which function I should differentiate. Okay, so like they have made this standard rule, but whichever is easier to differentiate, you will choose that as your differentiation function, and whichever is easier to integrate out of these two, you will choose that as integration. Simple logic, right? Like, no way to remember. If you want to, you can obviously, like I also remember, this is easier to remember, that islet rule. I is inverse trigonometric functions. How to integrate inverse trigonometric functions? Very difficult. Logarithm functions also integration is very difficult. Algebraic functions, yeah, it is easier than this. Integration of x square, integration of x cube by 3, x to the power 4 by 3. Okay, trigonometric functions, integration of sine, cos, minus cos, integration of cos is sine. So yeah, trigonometric functions is pretty easier than this algebra, but it depends, right? Whichever you find suitable, you can choose. Then exponential, e raised to power x, simple, e raised to power 2x, simple. So all of those integration are easier to differentiate, so integrate. So if we are here, okay, like if we are here, let me name this, choose this as your integration function. You don't have to remember uv, all those things. Like whichever you found suitable, you integrate that, and you don't have to remember this uv rule, u and v, right? You choose v this, u that. No, you are confused. So just simply, this one is the easiest to integrate, so you will choose this as your integration first, easiest to toughest. Okay, easiest to toughest, right? So yeah, this is how you integrate. So we'll do a few examples, from there you will understand that. Okay, I will give you homework. Okay, this x sin x cube x and all these things, right? You try to see which one is easier to integrate and which one is difficult, like which one is easier to differentiate. Out of these, which one is easier to differentiate? I think x is pretty easy to differentiate it. Okay, x is pretty easy to differentiate. Okay, so yeah, you can use that. Okay, and like any other thing, if you notice, you can do that. So like there are many types. That one was type 1. Okay, this one was type 1. So let me solve this anyways. So here I told you, right, x is easier to differentiate, because if I differentiate x, I will get only a 1. Okay, if I integrate, I will get x square, which is even more tedious to deal with. So what I can do, I can keep my x outside and I can integrate this. Now this sin x and sec cube x, this sec x is 1 by cos, sin by cos is tan x. So this will be tan x into sec square x. Why did it? Because to get this substitution, basically if I write my t as tan x, the differentiation of tan x will be sec square x dx. Okay, so that's why. And minus, don't forget this formula, du upon dx, which is 1. Again I will integrate this tan x sec square x dx, and overall I will integrate this function again with respect to dx. So this will be sec. Now what I can do, I can use the method of substitution. So I can write t equals to tan x and dt equals to sec square x dx. Okay, so dt is equals to sec square x dx. So what I can write this as t dt minus integration of again t dt, which will be t square by 2. Now what is t square by 2? T is tan, so this will be tan square x by 2, right? So yeah, this will be the like integration basically. Now what you can do here, right? I have this. This is also t square by 2 tan square x divided by 2 minus tan square x divided by 2. Now what you can do? Now do you know what is tan square? We don't know, right? But what you can do, you can convert tan square into sec square x. So if you convert tan square into sec square x, what will get? This will be sec square x minus tan square x is 1. So tan square x goes there. Okay, yeah, this will be sec square x minus 1 divided by 2 into dx. Okay, so this will be x tan square x divided by 2 will remain here minus. Now what do I know about sec square x? The differentiation of tan x is sec square x. The integration of sec square x will be tan x. So minus tan x divided by 2 integration of sec square x. Integration of minus 1 is simply x, and I have a minus sign ahead here also, so it will become plus x by 2. Okay, so what you can write? You can write this as simple I'm missing something. Yeah, you can simply write this as x, like by 2 you can anyways take common. Okay, x by 2 into tan square x plus 1. Now what is tan square x plus 1? Tan square x plus 1 is sec square x. Sec square x minus tan square x equals to 1. So tan square x plus 1 will be sec square x. So it is x by 2 into sec square x minus tan x divided by 2. Okay, so yeah, this is my answer. Also we have a plus c. Okay, so like either you can write it like this or you can write it differently. Okay, wherever they have finished here, right? Sec square x, that's why I had to write it like this. So further I can simplify this. This will be half x sec square x minus tan x plus c. Okay, so this will be basically B, right? My option B will be correct. X sec square x minus tan x plus c. Okay, so this is the case. Let's now do this type 2. Type 2 is similar only. What you do, you just assume, like I will give you this homework. I hope you have already done this. You assume like which one is easier to integrate. ln(x), no, I have only one function. So you might say, sir, then why will we use the chain rule, product rule? Yes, we will, because I have another function of x, that is x raised to power 0, 1, which is hidden, always hidden. So we'll assume 1 as u can v as ln(x). So I will differentiate 1, I will get 0. I will okay. No. I will integrate 1. I will get x and will differentiate ln(x), which will give me 1 by x. Okay, that I will do, and you will find the answer. Here also I have type 3. Both are pretty tedious, right? Both are pretty tedious to differentiate and integrate. Both are almost similar. You choose any of them. So here, right, what you have to do, like you have to assume a constant integration. So let me solve this, and from there you will understand. So basically it was islet. So from down to up I choose. So islet e was first, exponential was first. Okay, to choose for integration, so I will choose exponential. So here what I will do, I will evaluate this one. So this will be e raised to power 2x. Okay, not this, sin x into e raised to power 2x dx minus integration of differentiation of sin x, which is cos x, into integration of e raised to power 2x, which is e raised to power 2x by 2 dx. So this is equals to e raised to power 2x sin x by 2. Now what is this? Again I am getting something similar to this, just a difference is instead of sin x I am getting cos x. So again I will use the product rule, right? Again I will use this rule. Okay, use this by parts, integration by parts. So this is exactly what is happening. I am integrating by parts. Why? I will show you. So then what I will do, integration of this, right? So 1 by 2 will come outside, and then what I will do, this again I will keep my e raised to power 2x out inside, because that is the easiest to integrate according to the Eilert rule. So cos x will be outside, integration of e raised to power 2x dx, again I minus sin, then integration of differentiation of cos x, which is minus sin x, integration of e raised to power 2x, e raised to power 2x by 2 dx. Okay, so this will be e raised to power 2x by sin x by 2 e raised to power 2 sin x by 2 minus this is again e raised to power 2 sin x cos x divided by 2. Then this is like, what is this? Can you say me what is this? This is okay. I have a okay. What I can do, like I have a minus half also outside. Sorry. So this minus half is also outside, and this, right? This is plus. I can write this plus 1 by 2 e raised to power e raised to power 2x sin x dx. Now is this looking anything similar to you? Is it looking anything similar to you? Yes, right? Because this is just that I only. This is just that I only. Right? So what I can do, I can write here e raised to power 2x sin x divided by 2. Okay, minus, like I can take the minus sign inside, like this thing, right? This thing, okay, this thing is same as this thing, right? So whatever result I will get, let me name this as I. So this will also yield me the same result, I. Okay, so exactly that is what I will do. I will replace. This is the type 3. Okay, where you assume I. So this will be e raised to power 2x cos x by 4 minus 1 by 4 I. Okay, this is plus minus 1 by 4 I. So that I will go at that side. This is I only, right? This is I only. Okay, because I have like given the result of this as I. So this is only I. So 5I by 4 equals to e raised to power 2x sin x by 2 minus e raised to power 2x cos x by 4. I can take 2 common, right? I can take 2 common or I can take 4 common also. So I will be equals to e raised to power 2x divided by 5. This will be 2 sin x minus cos x, 2 sin x minus cos x. Okay, this is what my I will be. So this is my answer. So that's what you do. You simply replace whatever you found out with I. Okay, because that was the question itself. So like this is how you solve these type of questions. Generally trigonometric functions you have to use this type. So this is generally used for trigonometric and exponential functions, where you get back the same integration from where you started. Okay, that's very important. So here I have given you few standard formulas. If you want to remember, well and good. If you don't want to remember, you can directly like use this integration by parts. It will just take more time. Okay, that's the difference. Okay, 2 steps it will take. So this I have just solved it. This I have just solved these type of question. Okay, so you can remember directly this formula, or if you don't want to remember, you can directly solve this. So short notes, you add your short notes with a bit of proofs. Okay, with proofs, because that will help you remember things better. With proofs or intuitions. Okay, that will help you remember things better. Okay, so let's come to this type 4, right? So type 4 is similar only, but I have an exponential at the outside and I have f of x plus f dash of x, the differentiation of x. So which is like the integration of this will be simply e raised to power f of x. Okay, so how is this the case? So you can use the simple integration by parts and you can prove this, right? You can prove this, that you will get the exact same rule. Okay, so or what you can do, you can do the opposite. So you use the product rule here to differentiate. Use the product rule to differentiate, a chain rule. What do you see? First you will differentiate this function, that will be f dash of x, and you will keep this outside, and then you will differentiate this function which will be e raised to power x and keep this outside. So e raised to power x I will take common and I will get back with this. Okay, so exactly that is what is happening over here. Now if I have another thing, that is x f dash of x plus f of x, the integration of that will be x f of x. Again you use the product rule. Okay, if you differentiate on both sides, basically now what you will get, first I will keep this outside and differentiate this, which will be x into f dash of x. Then I will keep this outside and differentiate this, which will be 1. So it will be f of x plus x into f dash of x, and exactly that is what I am getting. Or you can use the by parts rule also. So by parts rule, what you will do, so basically islet, right? Islet. So here I have a x which can be easily differentiable, right? I can differentiate it easily. So which is differentiation is 1, so which is very good. So what I will do, I will keep this outside. Now I will keep the integration here, dx minus f dash of x, sorry, ddx of x, sorry, ddx of f of x, which is this, and what am I doing? Okay, I'm sorry, I should have started from here also, because I'm integrating here, right, not there. Sorry for that. So I will integrate here, right? So I will keep x outside and I will integrate f dash of x dx minus integration of ddx of x, which is 1, into again integration of f dash of x dx, which is equals to, also I have a I can use superposition, right? I can use the superposition. So this will be plus integration of f of x d of x, so which is x into f of x minus integration of f of x plus integration of f of x d of x, which is equals to simply, or like I have to also write plus c. I will write that later. So this and this get cancelled, right? This and this gets cancelled, so I will be left with x f of x plus c. Okay, this is what I will get, x f of x plus c. Okay, so yeah, that's the simple proof. You can do that. And here I have a question, same question like this. So I will just give you the hint for now. You have to think about something, right? Some simple plus minus 1 or something like that, then you will be able to solve this. Okay, so all this I'll solve this in the next lecture. Next is recurring by parts. Basically, like whenever I have to choose this I, right, I equals to something, and then I find I in terms of all the other things, so then di method is best, or di method anyway is best if you want to use a shortcut. So what is the shortcut? So if you have some form like this, x square e raised to power 2x dx. Now I know this is the some form of integration by parts, but I don't want to write that much things, so I want to write as minimal as possible. So what you can do, you can use the di method. So in di method, what you do, first you write d and I, you make a table of 2 columns, that is d and I, and you write the differentiation function here and you write the integration function here. So what I want to differentiate out of these two, I want to differentiate this x square, because integrating this will even make the mess even bigger. It will make it x cube, x raised to power 4, which I don't want. So here you will write x square, and here you write e raised to power 2x. So okay, where did I go? So now if I differentiate this, this will be 2x This will be integrate this will be e raised to power 2x by 2. And also at the end I will tell you another thing about sign that we will do later. So I want to go until my d goes to 0. Okay, so until my d goes to 0. Okay, so this will be 0, this will be e raised to power 2x divided by 4, and here it goes 0, right? So I will stop. So now if I stop, so what I will do, I will add signs also. This will be plus, first one will be plus, then minus, then plus. Okay, so now, okay, sorry, actually I made a mistake over here. This differentiation is simply 2. Okay, and this will be e raised to power 2x by 8. Okay, so now I will just cross multiply. I will multiply this with this, then I will multiply this with this. Not cross multiply, I will multiply the next terms, right? Next terms, this with this. And obviously, why do I stop here? Because even if I try to multiply this with anything, this will be 0 anyways. That's why we stop. So what will be my integration? My I will be simply equals to x square e raised to power 2x divided by 2 minus 2x e raised to power 2x divided by 4 plus 2 e raised to power 2x divided by 8. So I equals to x square e raised to power 2 minus x e raised to power 2x divided by 2 e raised to power 2x divided by 4. Okay, so yeah, this will be my simple answer. Of course, you cannot forget the c, constant of integration. Okay, so like I forgot to tell you that c is also known as the constant of integration. Okay, so next you solve this using DI method. I will solve in the next lecture. So what is the next method to solve integrations? So integration you can solve with the help of partial fractions. So if integrals of rational functions of type p of x above g of x, right? P of x by g of x are present, but degree of p of x is less than g of x. This is very important. Degree of p of x is less than g of x. Then only we can apply the partial fraction formula. Can be integrated by resolving the integrand into partial fractions. We can resolve the integrand into partial fractions. I hope you know partial fractions. If you don't know, we'll solve 3 cases, and from there you will understand what are partial fractions. Now, if the degree of p of x, is greater than the degree of g of x, what we'll do, we'll divide p of x by g of x till its degree is less than less, that is put in the form of this. So we'll understand this. When we solve these type of questions, we'll understand this. Okay, so this is the first question. So how do you evaluate? So simply, first thing what you observe is that degree of numerator equals to 0 and degree of denominator equals to 2, right? Highest degree. So obviously, or sometimes they say order also. So obviously I can use my partial fractions. So this is more simpler. Okay, if this was difficult, then I would have thought of something else, but we will use the basic method right now. So what I can do, this I can write this 1 by x plus 1 into x plus 2 equals to a by x plus 1 plus b by x plus 2. I should write this a and b as capital. Okay, so now what I can do, I can multiply x plus 1 into x plus 2 on both sides. This will be a into x plus 2 plus b into x plus 1. Now what I can do, if I put my x equals to -2, my b will be -1, and if I put my x equals to -1, my a will be 1. Okay, so anyways you could have seen it by far also that it will be 1 minus 1, but still first question, so we'll do it basics. So my I will be integration of 1 by x plus 1 minus 1 by x plus 2, and this will be whole dx. So obviously this is ln of mod of x plus 1 minus ln of mod of x plus 2 plus the constant of integration. So overall I can write this as ln of mod of x plus 1 divided by mod of x plus 2 plus c. Okay, so this is the case, so this is the answer basically. So you can solve it like this. This is like you use like this, right? This integration uses it needs two methods. First one is the substitution, second one is the partial fractions. Okay, so you have to understand, they will not give you like spoon feed you exactly, so you have to use your brain also, what to substitute and then what method to use. Okay, so like I have next few questions. This is for non-repeated single pole. When I have multiple poles but they are not repeated. Okay, and here if I have repeated poles, so you try to solve this if you already know what are the different methods by which you can use the partial fractions, right? You can divide this function into summation of different fractions. Okay, and here every case has degree of numerator lower than the degree of denominator, but there will be one case where my degree will be higher than the degree of numerator will be higher than degree of denominator. So what you will do, like here this is also complex pole. So first what you have to do, you have to convert this into some format where you can use the partial fraction. So what you have to convert, so basically I can say here my degree of numerator is greater than my degree okay. So what I will do, I will convert this p of x by g of x into d of x into functions like this. There will be r of x d of x plus this f of x, and I can name this any, like g of x will still remain over here into d of x. Okay, so yeah, this is what I will convert. So what I will do, I will just simply try to make this, right? I will simply try to make this divisible. Like I will use the long division method. You can use a long division method. Okay, or you can use some tricks. So here what I am observing, I have x square plus 1, and if I see something that x to the power 4 minus 1, if I have somehow, then I can write that like x square minus 1 into x square plus 1. Okay, and that x square plus 1 will get cancelled. So that you can do. So here what I can write, x raised to power 4 minus 1 plus 1 divided by x minus 1 into x square plus 1 dx. So integration of this will be x square minus 1 into x square plus 1 divided by x minus 1 into x square plus 1. Of course I have this plus 1 also, right? I cannot forget this plus 1. So this plus 1 will be present obviously, but I can write it separately. dx by x minus 1 divided by x square x square plus 1. Okay, so I can solve this separately, right? Now this can be solved with partial fractions because the degree of numerator is lower than the degree of denominator. So now like let's solve this. So this will get cancelled. Can I cancel anything else? Yes, right, I can cancel anything else also. What I can cancel? I can further write this x minus 1 into x plus 1 divided by x minus 1 dx. Now how to solve this? Basically this one I will name this currently, this one I will name this as I, okay, plus c. So this one will get cancelled again. This is I plus c. So this will be x square divided by 2 plus x plus I plus c. Okay, so how to basically like solve this? But before going into that, right, I want to show you another method. Okay, this is the method 1, that is the trick. That is the trick. And what is the method 2? Method 2 is basically you use long division. Okay, if you are not able to like think of anything, right, what trick you have to use, plus minus 1 or multiply divide, something like that, what you can do, you can always use long division. Okay, that will give you the answer. So what is long division? So whatever is in the denominator, right, whatever is in the denominator, you copy and paste that and you write it fully, okay, in expanded format. So this will be equals to x cube plus x minus x square minus 1 x cube minus x square plus x minus 1. Okay, next this will be x cube minus x square plus x plus 1. So I'm dividing by this, and what I am dividing? I'm dividing with x raised to power 4 because x raised to power 4 was here, if you remember. So x raised to power 4 is here. So now like how do you use long division? So what do you do? I have to get this number, right, x raised to power 4. So what should I multiply to get x raised to power 4? I can multiply x with this x cube to get x raised to power 4. So I'll write x here. So this will be x raised to power 4. This will be minus x cube plus x square plus 1. And obviously I hope you remember how to do the divisions. You change the signs, minus minus. So this will be 0, this will cancel out. This will be x cube minus x square minus 1. Now x cube is already present over here, so I will write x plus 1. Okay, and this will be x cube minus x square, and this is plus x is somewhere else. Yeah, plus 1. Sorry, this is minus 1 plus 1. Sorry, minus 1, right? So this is minus 1, and I have a plus x. I'm just writing this x so that like we can cancel other things. So this will be simply minus plus plus and minus. So here I will have a minus of x, which is a remainder. So my quotient is this, and if I multiply this with this, I will still have a remainder of this. Okay, so basically this is my quotient, and this is my this is my quotient, which is here, right, which is here. Okay, and the remainder function will be up over here. Okay, so okay, am I doing something wrong? That is what I'm trying to observe. Okay, I made a mistake over here. This will not be 1, this will be x. Sorry, my bad. So this will also be minus of x, and the thing that I was replacing, right, I won't replace. That is why I was thinking that why am I getting a wrong answer, right? So okay, this is x, okay, this is minus of x, sorry for that, minus of x. So this will become plus, so this will become plus, this will also become plus, and this will be minus, so this will be plus, so this will be 1. Okay, so like this is my remainder, right? So what do we mean by this? So basically what do we mean is that if I multiply x cube, I will copy this thing, like if I multiply with quotient, right, this thing with the quotient and add the remainder, like for the students who tend to forget this, they can use this, add the remainder up is 1, I will get my answer x raised to power 4. Okay, so now what you can do, now you can simply divide by this. So if I divide by this, what will you be left with? X plus 1 plus 1 divided by this x cube minus x square, this was this, right, this was this. So I can write x minus 1 x square plus 1 equals to x raised to power 4 divided by this x minus 1 into x square plus 1. So for the people who tend to forget this, I have simplified this thing. Okay, I have simplified. Like you might say, sir, I forget that this will become without any denominator, this will come with denominator. How is the case? You write it like this. What is remainder? Remainder means the remaining part, and the quotient I have to multiply with this divisor. I forgot, is it called divisor or dividend? I forgot, right? So if I multiply with this by what I'm dividing with the quotient, and if I add the remainder, the remaining part, I will get that back my this whole thing x raised to power 4. Now I will divide with this. Okay, and if I divide with this thing is this thing only, right? So this thing is that, so the resultant is this. Now you can simply integrate. This is integration of x plus 1 is very simple. Integration of this is with partial fractions. Okay, so for this, how to solve this, we'll do this in the next lecture. Okay, so like okay, we can solve this right now anyways. So what do you do now? Let's come to complex poles. So for complex pole, what you do, or like when you have higher order poles, right? So this one is easier to solve. Let's solve this I. So I have named my I as this. I is equals to integration of dx over x minus 1 x square plus 1. So I can't break this down into real factors. I have to break this down into complex factors, which is plus minus I. I don't want to do that. I don't want to do that. So what will you do? So you will do one thing, that you write this 1 by x minus 1 into x square plus 1 equals to, this will be simple, ax minus 1, and this, as this has second order, so I will have to take two coefficients and with the x over here and with the x over here. So this is the method that we use, bx plus c divided by x square plus 1. Okay, so now if I multiply this x minus 1 into x square plus 1 on both sides, I will get a into x plus 1 plus bx plus c into x minus 1. Okay, so now what you can do, like you can equate the coefficients, or you can put x equals to some value. So if I put x equals to, okay, I don't want to put minus I don't want to do that. So if I put x equals to 1, I will be left with this. So a will be equals to, for x equals to 1, a will be equals to 1 by 2. Okay, and okay, if a is equals to 1 by 2, now we can equate the coefficients. So what is the constant term? Constant term is a over here, and what is the constant term over here? This is bx and this is minus bx, this will be minus c. So equating constants, so a minus c will be equals to 1. This is equating constants, equating constants. So obviously from here I will be able to identify the value of c, which is minus half. Okay, c is minus half. Now what is b? So let's try to understand what is b. So again, if I equate the coefficients, so if I equate this time the coefficient of x square, right, this will be bx square and this is ax square. So a plus b, I will write in the next page, equating, as most of you know already partial fractions, so I'm not going too much details into this. Okay, I hope you know. If you don't know, you have to study by yourself. Like everyone knows, everyone have studied in college also and in B.tech also, in 11 and 12 also. So I'm not giving too much emphasis on this partial fractions. Equating coefficients of x square. So if I equate the coefficient of x square, what will I get? So here I can observe that if I multiply a with x square and this b with x, this will be bx square, but this c can never generate x square with it. So only a plus b into x square can generate, and on the left hand side the coefficient of x square is a plus b, on the right hand side the coefficient of x square is 0, because it is 0 into x square. I don't have any coefficient of x, I don't have any x square term, this is 0. So b will be minus of a, which is equals to minus of 1 by 2. So b is equals to minus of 1 by 2. Okay, so now what do we get if I equate this? This is a bit difficult to solve actually, to be honest. For complex pole they will not give this. This will be very lengthy. So a is 1 by 2, so 1 by 2 into x minus 1 plus b, and this is minus half, right? So this will be minus, okay, I can take the half outside, minus half into x plus 1 divided by x square plus 1 into dx. Okay, so like how to solve this? So what we can do, we can cross multiply 2, right? We can cross multiply 2. So individually we can solve this, right? So this will be simple only. This will be 1 by 2 ln of mod of x minus 1 minus 1 by 2, and if I cross multiply 2x divided by x square plus 1 dx, obviously I have to divide by 2 also, so an extra 2. I have a minus of outside, right? So keep that in mind. So this will be this will be integration of dx over x square plus 1. This is very simple, right? And this bracket has been closed, so this will be 1 by 2. I can take 1 by 2 common totally, ln of x minus 1, okay, and this will become minus of ln of x square plus 1. Okay, I hope you are able to understand it. I have substitution, like I have taken the substitution that t is equals to x square. I have taken that substitution. So yeah, if you do that you will be able to find out, and this is simply minus of tan inverse of x. Okay, so minus is over here, this will be simply minus of tan inverse of x, and obviously I have a plus c at the end. So this will be half of ln of mod of x minus 1 divided by mod of x square plus 1. This will anyways be like positive only. X square plus 1 is anyways always positive. X square is anyways always positive if I am giving real numbers. This will be minus, this is minus, right? Yeah, minus. Tan inverse x and plus c. So this will be my answer to this question. So this is my I. Okay, this is not my answer to this question. This was the answer to this I. This was the answer to this I. But what is my full answer? So here, right, I have to integrate this as well. You forgot, you have to integrate this as well, right? You have to integrate this as well. This x square plus x plus I plus c. So my answer will be x square. I'll copy this. What I will do is I will cut and take a new page. Reduce the size. X plus x square by 2 plus this, and what was the integration? The integration was very simple, right? But the answer came out very weird. So that is what happens. So this is my answer basically. Okay, this is my answer. So yeah, this is like a very weird expression. So next is trigonometric integrations. So if I have some format like this, what will you use? What format will you use? So whenever you have sine square, cos square, or sine square or cos square, anything, right, in square terms, okay, what you will replace for all of this? Divide numerator and denominator by cos square x. Why cos square x? Why cos square x? Because if we divide by cos square x, this will get cancelled. This will be tan square x, and here I will get sec square x. So tan x's differentiation is sec square x. So yeah, that format is there, and the same reason. Okay, or you can divide by sine square x as well. You will get cos x square x, and you have to get cot x, right? So like the cot x relation. So but we prefer tan because we use tan, that's why. So then you replace or substitute tan x equals to t. You replace or substitute tan x equals to t. Okay, that is what you do. Okay, so these are homeworks for you. You can evaluate this right easily. You divide by cos square x on both sides, and then you use the method of substitution. Okay, here again trigonometric integrations, right? So all these things are present. So here what you'll do, here you will use a half angle formula. So what is half angle formula? If you remember correctly, you will replace everything with tan x by 2. So sin x is equals to 2 tan x by 2 divided by simply 1 plus tan square x by 2. Okay, and your like this becomes 2 sin x by 2 cos x by 2, and that is sin 2x, that is sin x. And what is your cos x? So if you remember, cos x is equals to 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Okay, so yeah, that is the case. Okay, so like what I used to do, I used to write this in shortcut. So what I will write this in shortcut is s equals to 2t by 1 plus t square. I will write this c equals to 1 minus t square by 1 plus t square. Do not waste time in just writing tan, cos, all those things, right? I save time in this, right? So yeah, that is what you do. Then what you do, you replace like I wrote over t over here. So you replace t with tan x by 2, and you know what is dt? Dt is sec square half into sec square x by 2 into dx. So yeah, that's how you solve this basically. So I have given you example, try to solve this, and in the next lecture I'll solve all of these questions, right? Don't worry. So yeah, this is the end of this lecture. So I wanted to quickly finish this off because this is not that important, but it is important for you to understand to solve the bigger questions which will actually come in the examination. Okay, so yeah, you just go through all the questions, and in the next lecture I'll solve all the questions. Thank you for watching. 20 मिनट कटेगा, 20 मिनट, हाँ 20 मिनट कट 17 मिनट, 1 घंटा 20 हो जाएगा.